All right, next we're going to use sine, cosine, and tangent to find missing values. And some of them may be sides, some of them may be angles. So you have the same set of steps. The first thing you're going to do is look at your figure, decide whether you need to use sine, cosine, or tangent. And that will depend on what parts of the triangle you have. For your angle, if you have the opposite and hypotenuse, you would use sine. For the angle, if you had adjacent and hypotenuse, you would use cosine. And for the angle, if you had the opposite and adjacent, you would use tangent. Okay? Then you set up the equation. If it's sine, you don't use all three of these. You use whichever one you determined you needed to use in step 1. Okay? If it's sine, you would write down sine of your angle, and you would put your angle measure right here if you know it. If you don't know it, you would just put its variable equals the length of the opposite side over the length of the hypotenuse. Cosine, tangent, the same. You use their formulas. And then the last step would be to go through the steps to solve for whichever missing variable there is. Okay, so let's do an example. In this figure, they want us to find the length of side EF. So I'm going to put my variable right there. I'm looking for the length of this side from E to F. I'm going to call it X because that's what I'm looking for. My first step was to decide whether I need to use sine, cosine, or tangent here. So you look at what angle you have, or which one you're looking for. Here's my angle. For that angle, I have the opposite leg, okay? And I'm looking for the adjacent leg. I know nothing about the hypotenuse, so that's out. But I have opposite and adjacent. Which uses opposite and adjacent? Is it sine, cosine, or tangent? Well, hopefully you remember that tangent is opposite over adjacent, so I need to use tangent. I could not use sine or cosine because I know nothing about the hypotenuse. My next step is to set up the equation. Okay, so tangent of the angle. Do I know the angle? I do. It's 64 degrees. So tangent 64 equals the opposite leg 20 over the hypotenuse, or it's not hypotenuse, over the adjacent x. Okay, so tangent of the angle equals opposite over adjacent. And now we evaluate and solve using a calculator. So when you're solving this, anytime your x is in the bottom of your ratio, the first thing you have to do is multiply by x to get it out of there. And when you do that, you have to multiply the other side by x. That's our rules for solving. So now I'm going to bring it over here, x times the tangent of 64 equals 20. Now remember, tangent 64 is just some decimal number. I'm going to leave it written as tangent 64, then I have less rounding. So I want to solve for x. It's multiplied by the tangent of 64. How do I get rid of that? Well, the opposite of multiplying by the tangent of 64 is to divide by the tangent of 64. And whatever I do on one side, I have to do on the other. So I get x equals 20 divided by the tangent of 64. And now I just take out my calculator and find that number. Okay, so if I'm using the calculator that's on the computer, I would put 20 divided by, whoops, sorry, I gotta clear that, 20 divided by, and then remember to find tangent 64, you have to put 64 first and then push the tangent button. Now, the number that's displayed right now is the tangent of 64. So to do what it says here, 20 divided by the tangent 64, I have to push my equal sign. So you put 20 divided by 64 tangent and then hit equals. And I get my answer of 9.75, I believe. It wanted it rounded to the nearest hundredth, which is 2 places after the decimal. Okay, so we follow the same basic steps, but our problems will change drastically depending on what we're given. So here's another example. What is the length of JL? So where is JL? That's my line going from J to L. I'm going to call it X because I know, so that I know that's the part I'm looking for. So again, first step, look at your figure and decide whether you need to use sine, cosine, or tangent. Well, here's the angle that I was given to work with. Do I have opposite, adjacent, hypotenuse? What do I have? Well, my x that I'm looking for is the opposite leg for that angle. And this 18.4, notice, is my hypotenuse. So I'm working with opposite and hypotenuse. What uses opposite and hypotenuse? Sine, cosine, or tangent? Hopefully you remembered that sine is opposite over hypotenuse. So that's what I'm going to be using. I set up my equation. Sine of the angle, do I know my angle measure? I do. It's 48 degrees. So sine of my angle equals the opposite leg, x, over the hypotenuse, 18.4. Okay. Now I use a calculator and algebra skills to solve this. This one is going to be much easier to solve than our previous problem. Okay, and the reason for that is because x is in the top of our fraction. So all we have to do to solve this is multiply by 0.84 to get that, or excuse me, 18.4 to get that out of the denominator. And I have x all by itself, so I'm pretty much done. I just need to use my calculator to find that answer. And depending on your calculator, your keystrokes will work differently, but let's use the one that's on the computer. Okay, so if we're using our calculator, again, here's what we're calculating is 18.4 times the sine of 48. So you may want to find the sine of 48 first. So again, put the number, your angle, then hit sine. Okay, and the reason we're not using the inverse is because we know the angle. It's when you don't know the angle, that's when you use inverse. So we put 48 sine and then multiply by 18.4. And we get 13.67 is our answer. Okay, so the length of that side JL is 13.67.